14.5, graphs of sine and cosine functions are called sinusoids. One method, it sounds like a doctor's prognosis for you. It's a sinusoid. One method to write a sine or cosine function that models a sinusoid is to find values of a, b, h, and k. And the nice thing is we've already worked on it one direction. Now we're going to go backwards. And I apologize. You were supposed to have the graphs and we're supposed to write the equation. So I'm going to have to draw the graph and you copy it. So what we did in the earlier section is you were given the equation and we graphed it. Now I'm going to give you the graph and we're going to come up with the equation.
We had to do this on one of them, didn't we?
Yeah, I think one of them. Yeah, it was kind of a laying the foundation problem, like can you sort of figure it out backwards. So if I have y equals a sine b times the quantity x minus h plus k, or y equals a cosine b times the quantity x minus h plus k, absolute value of a is the amplitude, 2 pi over b is the period, h is a horizontal shift. Horizontal is left, right. Vertical shift is up, down. I will tell you that in each of these and in this section, we're not going to do h shifts. We'll do that in pre-calc, but in Algebra 2, I'll be happy that we work on A, B, and K this year. Okay, so here's what I need you guys to do. I need you to draw a grid. We're going to make 2 to the left and call the second one negative pi over 2. Okay, so I'm going to give you a moment just to get the grid, and then we'll start plotting. So what would be the value of each tick mark? Pi over 4, okay? Each tick mark is really a distance of pi over 4. All right, so the first point we're going to plot is at 0, 2. Then halfway, it's not even to the first tick mark. At the halfway, we're going to go up to 5. Then halfway, we go down to negative 1. Oops, I missed one here. At the first tick mark is here. Halfway is back here. Well, it's really at pi over 2. Then halfway it's here. So like every half of a tick mark I'm plotting, okay? So, I'm sorry. I'm at 0, 2, then halfway I go up to 5. To the next tick mark, so it's a half a distance, I'm back at the 2. Half a distance, I'm down at negative 1. Half to the pi over 2 is here. So every time I'm going halfway, continue it a little bit more. Okay, so here is the graph. So I'm going to take you through 4 steps in order to come up with these values, okay? Everybody have the graph now? Once you see the pattern, then you can just follow the pattern. So step 1 says find the maximum value, capital M, and the minimum value, little m. So when they ask you for a maximum or minimum, it is implied it's a y value. So what is the maximum y value? 5. What's the minimum? Negative 1. So capital M is 5, little m is negative 1. It says identify the vertical shift k. The value of k is the average of the maximum and the minimum. That's capital M plus little m over 2. So it's 5 plus negative 1 over 2. So k is a value of 2. It says what you're going to do to decide whether you want sine or cosine is you're going to draw a midline through y equals k. And in this case, that's y equals 2. So let's go back to the graph. And if it's y equals 2, what this is doing, so it's taking the x-axis and it's shifting it up 2 units, okay? So then, do you see that the graph is really oscillating and it's going through the midline? So we're going to want to use the sine curve, okay? We're going to want to use the sine curve, and we now know what k is. The amplitude, remember, is from that midline, how far up and down are you moving? What is that number? 3 units. Now, since it goes up 3 first, a is positive. If it had been at 0, or crossing here and went down 3, a would have been negative, okay? But since it went up, a is 3. Now the period length is how long does it take to repeat the cycle? So it's going here and it's stopping at pi over 2. Do you see that? That's how long it takes to complete one cycle. So the period is pi over 2. But if you recall from our graphing of sine and cosine, the period is also equal to 2 pi divided by b. So I can cross multiply. This is a proportion. So I get 4 pi equals b times pi. Divide by pi, and b is 4. Now I can write the equation. Y equals a sine b times the quantity x minus h plus k. Now h is 0. I'm not doing any left-right shifts here. So y equals 3 sine 4x, and it went up 2, and k was 2. Okay. We'll do another one. So you're going to go through these steps until you get the hang of it. All right, so again, I apologize. You should have had the graph. Everybody have the graph? Okay, now, do you notice that the midline is the x-axis? So that means k is 0. And I'm not doing any left-right, so h is 0. Now, what you want to do is, do you notice it starts at the amplitude, so I want to use cosine. So I want to write y equals a cosine b, the quantity, x minus h plus k. Now to find a, it's negative 2, isn't it? Because it's starting down at negative 2. Then we need to figure out what's the period length. How long does it take to repeat? If you start where x is 0 and just go to the next spot, do you see then that spot is the length? So the period is 2 pi over 3. and the period is 2 pi over b. Now use your thinking caps. What's b? 3, okay? You don't need to cross multiply, that would be goofy. So this is y equals negative 2 cosine 3x. That's it. Okay, are we starting to get the hang of this? Okay.
And you're putting it as A instead of amplitude so we can have it be negative.
Yes,
Okay.
good job. I didn't call it amplitude. Good catch. Good catch. Absolutely. All right, so here we go. Okay, so let me describe these points to make sure you're understanding what I'm doing. The first one's at 0, negative 1. Then I went halfway up to 1, another half a unit back down to negative 1, half a unit down to negative 3, half a unit to negative 1, half a unit up to 1. So now the midline has changed. You want to go halfway between the max and the min. So where is the midline? Negative 1. So that's automatically telling you k is equal to the midline. So it's k equals negative 1. Do we want to use sine or cosine? Sine, because it's touching right there. If it's at amplitude, it's cosine. So good job. We have y equals a sine b times the quantity x minus h plus k. So we also know h is 0. What's a?
It's
2, and it's positive. Then what's the period length here? How long does it take to repeat? No, not 1. To 2, right? Right here. It does a whole cycle to 2. So this is 2 pi over b equals 2. I'll make that 2 over 1 and cross multiply. So b is pi. Now I can write my equation. So I get y equals 2 sine pi x minus 1. Don't forget about the k value. Okay, we're not going to do, I think I only have 3 on yours, right? And then the 4th one's a table?
Mm-hmm.
Good. For some reason I didn't delete it on mine, but. Okay, now we're ready for this one. It says another way to model sinusoids is to use a graphing calculator. The table below shows the number of kilowatt hours K in thousands used each month for a given year by a hangar at the Cape Canaveral Air Station in Florida. The time t is measured in months, with t equals 1 representing January, so t equals 2 would be February, and so on. It says write a trigonometric model that gives k as a function of t. So take out your calculators, and first of all check your mode. It's assumed radians. And then what I want you to do is after you check your mode, we're going to press stat.
So we should be in radians?
You should be in radians. It's always assumed radians unless it says something about the angles are in degrees.
Okay.
Otherwise, it's assumed radians. That's why I keep pushing you to work in radians, because at most, like 95% of the time, it's radians. So on edit, we're going to press enter. If you already have stuff in your list, you arrow to the tippy top and press clear and enter. Do not press delete, because you'll delete the list, and that's going to be a problem for us, and we'll have to reinsert it, okay? But go ahead then, once you clear out your tables, your lists, in list 1, we're going to put 1 through 12, and in list 2, you're going to put the kilowatts. The good news, as you're typing, I can hear your calculators going. Remember we did linear regression, we did quadratic regression, we did exponential regression. Now we're going to look at trigonometric regression, okay? Okay, you guys ready? Now you're going to press second mode. And now we're going to go back to stat, arrow to the calc. And I want you to take a moment and just kind of look at these. You can see linear regression, quadratic. It'll do cubic, like if your data is describing an x cubed graph. Quartic is an x to the fourth. Then for some reason they have a linear regression again, but just switching the order. Do you guys know what ln regression might be? We did ln earlier. What was that?
Wasn't that like logarithm?
Yes, the natural logarithm. So let's keep going and just look at some of these. So exponential regression means a times b to the x. Power regression, logistic, and then there's the sign. You should be able to just press enter. And then what I want you to notice is their general equation is a little different than the one I have. This says y equals a times sine the quantity bx plus c plus d. Remember, ours was b times x minus h plus k. But it's okay because they tell us what it is. So then here's what we're going to do. This is so easy. It's going to be the letter k equals 23.9 sine the quantity 0.533t minus 2.69. Close that parenthesis. And that is it. Any questions?